Hello everyone, welcome to the challenge question walkthrough for Edexcel's Pure Year 1 review exercise 2. Okay, for our first question, the diagram shows a square ABCD on a set of coordinate axes. The square intersects the x-axis at the points B and S, and the equation of the line which passes through B and C is y equals 3x minus 12. And part A asks us to calculate the area of the square. So, we know that the line passing through B and C, so this line here, is given by the equation y equals 3x minus 12. So we can use this equation to find the coordinates of B and C. So they are the intersection of the coordinate axes, so where y equals 0 and where x equals 0. So if y equals 0, then we get 3x minus 12 equals 0, so x equals 4. And where x equals 0, we get y equals minus 12. And so we know that the point B is going to be 4, 0, and the point C will be 0 minus 12. Okay, so to find the area of the square, all we need to do is find the length of one side, and we can find the length of BC using these coordinates here. So if we think about the triangle OBC, that looks something like this. And we know that B has the coordinates 4, 0, so this length here is 4, and the length of OC will be 12. And so we can find the length of BC using Pythagoras, so that will be the square root of 12 squared plus 4 squared, which gives us the square root of 160. And so the area of the square is going to be equal to 160 squared, which is 160 units squared. Now for part B, we're asked to find the coordinates of S. And I think the easiest way we can do this is to consider what the equation of the line AD will be. So we can see from the diagram and the fact that ABCD is a square that BC and AD are parallel. So we know that the line AD will have the same gradient as the line BC. So we know that the equation has the form y equals 3x plus c for some constant c. And to work out the constant c, we need some point on the line AD. And we can find that by finding either one of the points AD. Let's go for A. So to find the point A, we can think about the symmetry of a square. So if we think to go from C to B, we need to go 4 along to get to B, and then we need to go 12 up. So to get from B to A, we're going to have to go 12 along, and then 4 up. And as we know, B's coordinates are 4, 0. We're going to add 4 to the y coordinate of B to get A's y coordinate, and then take away 12 to get A's x coordinate, which will give us minus 8. And so these are the coordinates of A. And to find the coordinates of S, all we need to do now is find the equation of the line going through D and A. So plugging minus 8, 4 into this equation here, we get 4 is equal to minus 24 plus C. So we get that C is equal to 28. So the equation of the line going through AD is going to be y equals 3x plus 28. And now the coordinates of S is where this line intersects the x-axis. So this will be where y equals 0. So when y equals 0, we have 3x plus 28 is equal to 0. So x is equal to minus 28 over 3. And so the coordinates of S are minus 28 over 3, 0. Now question 2 asks us to prove that the circle x plus 4 all squared plus y minus 5 all squared is equal to 8 squared lies completely inside the circle x squared plus y squared plus 8x minus 10y equals 59. So first of all, for the first circle here, if we call that C1, we know that C1 is going to have a center of minus 4, 5, and a radius of 8. And now if we look at our second circle, if we call this C2, To find the center and the radius of this circle, we have to complete the square to get it into the form x plus a squared plus y plus b squared is equal to r squared. So completing the square on the left hand side, if we group together the x and y terms, so x squared plus 8x plus y squared minus 10y is equal to 59. Then completing the square for the x's, we're going to have x plus 8 divided by 2, which is 4 squared, and then we have to take off the extra 16. Then for the y's, we're going to have y minus 5 all squared, and then we're going to take away the extra 25, and that equals 59. Adding the constants to the right hand side, we have x plus 4 squared plus y minus 5 squared is equal to 59 plus 16 plus 25, which gives us 100. So now we can say that C2 is a circle with center minus 4, 5, and radius the square root of 100, which is 10. And so you can see that the circles have the same center at minus 4, 5, but the first circle, C1, has a smaller radius, so lies completely inside the second circle. And we call these two circles concentric because their center is the same, but their two radii are different. So they'll look something like this, like pond ripples. And so you can see if this is C1 and this is C2, C1 lies completely inside C2, as the question asked us to prove. And for question 3, we're asked to prove that for all positive integers n and k, n choose k plus n choose k plus 1 is equal to n plus 1 choose k plus 1. So for this question, we're going to have to use the n choose r formula. So n choose r is equal to n factorial over r factorial times n minus r factorial. And this will come in very useful for the rest of the question. So if we have a look at the left-hand side of this equation, first of all, and we're going to try and manipulate it so it looks like the right-hand side, n plus 1 choose k plus 1. So we know that n choose k from the formula up here. It's going to be n factorial over k factorial times n minus k factorial. And then n choose k plus 1 is going to be exactly the same, but we're going to replace k with k plus 1. So here, being careful with the negative, minus the entirety of k plus 1 factorial. So if we want to put these two fractions under a common denominator, then we can multiply top and bottom of the first fraction by k plus 1. So on top we get k plus 1 times n factorial over k factorial times k plus 1. So that's just k plus 1 factorial, n minus k factorial. And then for the second fraction, we're going to have to multiply top and bottom by n minus k. So on the top we have n minus k, n factorial. On the bottom, k plus 1 factorial. And then n minus k plus 1 factorial times n minus k, which is going to be n minus k factorial. So now our denominators match. And so on the top, we're going to have k plus 1 times n factorial plus n minus k times n factorial, all over k plus 1 factorial times n minus k factorial. And if on the top we factorize the n factorial out, we'll have n factorial times k plus 1 plus n minus k, all over k plus 1 factorial n minus k factorial. And the k's on top will cancel. So we have n factorial times n plus 1 on the top, which is just n plus 1 factorial, all over k plus 1 factorial times n minus k factorial. And here, if we rewrite n minus k factorial as n minus 1 minus k minus 1 factorial, so the ones will cancel, then what we're left with is the formula for n plus 1 choose k plus 1, which is exactly what we wanted to prove. So this is equal to the right-hand side as required. And our final question, question 4, we're asked to solve in the interval 0 degrees is less than or equal to x is less than or equal to 360 degrees, the equation 2 sine cubed of x minus sine of x plus 1 is equal to cos squared of x. So first of all, you should know that you can rewrite cos squared x as 1 minus sine squared x. And doing this will allow us to write the entire equation in terms of sine of x. So we'll have 2 sine cubed x minus sine of x plus 1 is equal to 1 minus sine squared x. And we can cancel the 1's on each side of the equation, and we're left with 2 sine cubed x plus sine squared x minus sine x is equal to 0. Now we can take a factor of sine of x out to ensure we don't lose any solutions where sine of x is equal to 0. So we have on the inside 2 sine squared x plus sine of x minus 1 is equal to 0. And we can factorize the inside there to get 2 sine of x minus 1 times sine of x plus 1. That is equal to 0. So from the 3 brackets, we have either sine of x is equal to 0, sine of x is equal to half, or sine of x is equal to minus 1. So if we draw the graph of y equals sine of x in the interval that they asked for, so between 0 and 360 degrees, that will look something like this. So starting at the origin, going up, and then coming back down, and back up again. Then if we draw lines where sine of x equals 0, a half, and minus 1, if I do 0 in red, that will be just the x-axis here. And I'll do a half in blue, so that's somewhere here. And then finally, minus 1 I'll do in purple, so that is right at the bottom here. And you can see for sine of x is equal to 0, we have 3 solutions, here, here, and here. So the first is at x equals 0 degrees, the second at 180, and finally at 360. And for sine of x is equal to a half, we have 2 solutions. The first where x is equal to 30 degrees, and the second where x is equal to 150 degrees. And finally, where sine of x is equal to minus 1, we have 1 solution, and this will be at 270 degrees. And so our solutions are x equals 0 degrees, 30 degrees, 150 degrees, 180 degrees, 270 degrees, or 360 degrees. And those are our solutions. And that is the end of the challenge question walkthrough for Edexcel's Pure Year 1 review exercise 2. I hope you enjoyed, and I'll see you in the next video. Thank you for watching.